Hello? From here, the system gave me 12 horsepower. Are you seeing it?
As per outdoor to use.
As per outdoor to use. And it's giving me 129%. Okay? And that's because I did something very crazy right here. Let me change this back. So now it's giving me 14 horsepower. And the weight is 111. But that's by the way. Let's continue. So here I go to my piping. The way the piping will be designed on site, based on the structure of the building, I will impute the same thing. Where I want my outdoor to be, the distance from my outdoor to the first indoor, I want to impute all of those values into this piping design. Okay?
Sorry.
Yep.
The designer itself, the designer needs to come and see the structure to know how
That is why most times when you want to do a DRV system design, the designer will always ask you for what? Drawing. He will tell you drawing, because from the drawing you'll be able to deduce the distance between this point and this point and this point. So you can now put the distance of the piping. Okay? Because the piping distance can affect the size of the pipe.
So this piping should be done during the building process and not after the building.
It can be done before and it can be done after.
Okay, it can be done surface or common.
And be done before and be done after. So now, looking at this, if I decide to make this, let's say 60 meters. Okay, so I'm changing meters. Did you see that? From the outdoor to the first wide branch, I made the length 100 meters. It changed the size of the liquid line to 5.8. If I reduce it to like say 30 meters, it drops. So you see the distance between your indoors, outdoors, from wide branch to wide branch, they are all very important. That's why drawings are very, very important. Okay, so even though the designer is not able to get a drawing, he might need to just go and do sketch, a simple sketch on your own, and then use your tape to measure distances and confirm for him, so that he will be accurate with the piping design. Because you know your compressor is just pushing your refrigerant. So if the piping is not accurate, the system will not be able to give you the right pipe size. Is it clear? So I will now let me assume the length for the rest. Let's say from here to here is 5 meters. From here to here is 5 meters. I'm just going to assume most of the length. Let's say here is 5 meters. Let's say here is 6 meters. Let's say here to here is 6 meters. Let's say here is 2 meters. 2 meters. Also, the elbows, the bends, because as your pipe is traveling, it might be need for you to include elbow. Maybe you come across a beam with a column. You can't start breaking the beam when you call it. That's the structure of the building. So you have to introduce elbows. So those elbows are also representing pressure loss points. Because your gas flowing through an elbow, it will hit the wall and then divert. You understand? So that will also be included in your design. How many elbows is a pipe passing through at every point? The design man will also include it. So when you see your drawing, he's knowing, okay, there should be beam here, column here. So if I'm passing here, I'm passing through 3 or 4 elbows. So you also include that in his selection. Let's say here I pass through 4 elbows. Here, let's say 4 meters, 1 elbow. Here, 5 meters, 2 elbows. Here, just 3 meters. Here, 2 meters. Now, the system has generated a final design for us. It's giving us 16 horsepower outdoor now. After we have introduced all our piping lines. Now you see from the outdoor, it says we are using 1/2 inch and 1/1/8 from this outdoor. I see it. Now it takes a wide branch. See the wide branch name. It's telling you there. This is the wide branch link, or the left net. That is going to divide this pipe coming into two. Mind you, this pipe here this line is representing two pipes.
Yeah. Yes.
Liquid and gas. Yes. Okay. Now this ref net KHRP is also having two ref nets inside. One liquid, one gas. Okay. So it takes this ref net and the ref net will divide the pipe into two liquid and two gas. Now one liquid is going here, which is 38. One liquid is going down, which is also 38. One gas is going here, which is what? 5.8. One gas is coming down, which is what? 5.8. No. 7.8. 22.2. I don't see the pipe size. So the pipe going here is 38 and 5.8. The pipe coming down is 38 and 7.8. See 22.2 mm. Are you seeing it? Now, once it gets to this point, it travels 5 meters from here to here. 5 meters. And then it takes another wide branch. This wide branch here. To divide these two liquid and gas into two again. One enters here. One entry here is what? 1/2 inch and quarter. Then it continues down again. With the same 38 and 7.8. I'm coming to this point. And then it takes another wide branch to 5.8 with 8, and then it drops. The same 38 continues, but the gas line changes to the reporter now. So that the pipe is either maintaining the same size or is reducing.
To get more pressure.
Exactly. To maintain the pressure. So at this point now, after branching to this point, the gas line is dropping from 19 to 15. The liquid line is still maintained. Then it drops to this last one, 1/2 inch and quarter here, and then 1/2 inch and quarter down. So this is the pipe you are going to install on site, following this pipe design. Yes, you have a question.
Sorry, just for clarity purposes. The pipe size, may have seen something else there. Calling something as if there's any kind of
you know what?
conversion. Yes,
let me change the units.
Okay.
Is it clear now?
I know.
It's clear now, right?
Yes.
Good. So now you see, from the outdoor, from the outdoor we have 1/2 inch and 1/1/8. This is one you know.
Yes.
It takes wide branch. From the wide branch, 38 and 5.8 enters here. And then 38 and 7.8 continues down. It gets to this point, takes another wide branch to connect to the indoor. Now you have 1/2 inch and quarter going to the indoor. And then you have, sorry. Half inch and quarter going inside, then 38, 7.8 continuing. So you see, this selection breaks down your pipe design for you. So you understand from this how to run your pipe. So you have to follow these designs strictly. And if you also pay attention, these wide branches, they are quite different. The wide branch here is KHRP 26A72. This one is 26A33. So the wide branch too are different. Okay? So you are going to get this design from a design person. And just before you do any glazing, you cut your pipe, you lay your pipe, you look at your drawing, which pipe is coming here. You look at it to the 8, you measure the length, go to the 8. What is coming next? Which wide branch? You check the wide branch. You put it there, you tape it. You lay your pipe down first. Because if you don't confirm your pipe sizes and then you do your welding, then you come back to confirm that you have put the wrong pipe, you have to then cut again. So first, you lay your pipe to connect the tape for each section. After doing that, you go back again and confirm what you have done before you start doing any welding. So you've seen it now that your job basically has nothing to do with pipe sizing. It's just give me design, let me go and follow your design and install. Very clear. I believe all of us here know how to do welding. So if you are a good technician that knows how to do brazing, VRV system shouldn't be an issue for you at all. It's just following simple design. Look at design, put your pipe. Look at design, put your pipe. Look at the white branch, put the same white branch size there. You connect. Is it clear? Any question? Now in the end, hello. You can see that in the end here, based on what we have done, the system has not even done a calculation to tell you additional gas that you put after commissioning. Are you seeing it? So based on your pipe lengths and sizes, it has done calculation for you. So once we are done with this, we'll just go and print the report. Create a report, yes, save. Desktop, yes. And then a report like this is printed for us. So you are going to get a report like this from your design person. In the report, hello, one house, please. In the report, it will show you the total pipe length you are going to use. See. To tell you your copper pipe for quarter, you are buying 14 meters. For TV8, you are buying 29 meters. For half inch, you are using 44 meters. It's even telling you the one that is soft pipe, the one that is hard pipe. Are you seeing it? So it's telling you all the pipe you are going to buy and their length. So this system generates your BOQ for you, total quantity of materials you need. And also, it will also show you your layout like this. So you will get a document from the design person like this that will show you all of this. So with this, you can easily prepare your quote and give to your customer, because you know you are buying 5'8", 30 meters. You calculate the cost, all of those things. Maybe you might not add extras more, just in case the pipe increases on site. If system is 30 meters, you might say 32 meters, 38 meters like that, and then you quote for this. Very simple. Any question?
My question is, like for instance,
Yeah, go ahead.
for instance, if a customer buy this VRV,
Yes.
does it comes together with the design as a manual inside, or you see after they have bought it, you now go to the site and they will now make another, give you a drawing of the place, now send for the designer.
When the customer says, I want to use VRV for, now, two things. Either the building is set, is already constructed already, or is it an upcoming project. Okay? If it's an upcoming project, you tell him, Oga, let me see your drawing, so that my design person can do calculation and tell me each of these space will require 2 horsepower, 3 horsepower, and then he will do a design based on the design, the building drawing that you have sent to the design person. And with that, you can generate this BOQ and give to you, to price and give to customer. Okay? If it's an existing building already, the same thing can be requested for the drawing of this building. If it's not available, then it now falls on you as technician to now look at the rooms one by one and calculate the capacity of the AC that will cool each of the rooms. You now generate it. You say, okay, master bedroom now 2 horsepower and a ceiling concealed. Madam bedroom now 2 horsepower but now 1 mounted. You list all of these things. And we'll also need it like a sketch so that we know how the pipe will travel and the distance, so that we can have accurate piping sizes. Okay? To help the design person to generate this BOQ and give to you. So this can be done before or after the building is ready. But it's better to be done before. But after, it's still possible. Is it clear? Fine, you have a question.
Yes, I will.
You have a question. Or should I proceed? Please ask a question.
Yeah. Now, what I want to ask is
Yeah.
from the outdoor,
Yes.
yeah, there is only one pipe, this pipe is
Only one pipe, liquid and gas.
they are running out of. So from the outdoor, that's where we tap all the other.
Exactly. Because the outdoor is your condenser.
Yes.
So liquid line from the outdoor will tap to all the indoors. The same way with the gas line from the outdoor will tap to all the indoors.
So
Branching,
we have to
branching.
put something like T.
So branching, branches.
That's the white branch
As
I
when
told
we
you
have
about.
just to do the welding, we put something like T.
Not just the T.
Everywhere.
Both, it's not a T. Call it white branch. It's white.
White branch.
Okay. That's, I showed you those things having plenty numbers. Because as the pipe is coming, you know it will, one will go like this, one will go like this. That point is always what we call white branch. To divide the pipe into two. So is it clear now?
Yes.
So don't be scared. The design aspect is not your problem. Okay? Design pipe sizing is not your problem. What you need to understand is if you get a design, follow what has been given to you. Okay? The pipe sizing is not up to you. It's up to the designer.
After the question,
Please ask.
let's say for in the case of maybe the outdoor is off. Can the white branch be placed the wrong way that will affect the indoor unit not to receive? Or
Yes, we are going to discuss that in the installation now.
I want to ask, assuming we have first floor, second floor, and fourth floor,
Yes.
the sketch you are going to take to give a design plan,
Yes.
are you going to take the calculation meters for the first floor, second together, and we are going to
Now,
make different for
if there is a design already,
Mm.
if there's a design will show ground floor to show the plan of ground floor, to show plan of first floor, it will show plan of second floor. Now, the design person can use one outdoor or one system to cool all the floors. That's option one. That means he will then travel from ground. If you keep the outdoor on the ground, the pipe will travel and enter ground floor first, and then climb second floor, and then climb third floor. The same person will, from the design, he will know, okay, each floor to floor is 3 meters or 4 meters. He will see it in the drawing there. Okay? But if there is no drawing, you will have to provide this information to the design person.
You are measuring
The same, exactly. The same way if you want to keep the outdoor on the roof. He can't go from the roof and serve ground floor first floor, you know. He will from there serve second floor, come down, first floor, come down, ground floor last. So depending on how the system is, that's how it will be served. Any other question?
Yeah.
Please ask.
Now, so we take here.
Okay.